Hello students, now we will discuss resolution of a vector. Resolution of a vector R as shown in the diagram directed from point O to C can be resolved in two vectors, vector P and vector Q along the direction making an angle theta and phi with the vector R. Now, as shown in the diagram, vector P, the direction of vector P makes an angle theta with the vector R, and direction of vector Q makes an angle phi with the vector R, as shown in the figure. Now, with OC as diagonal and two adjacent sides along direction of P vector and direction of Q vector, complete the parallelogram OACB. The parallelogram OACB. Then, according to parallelogram law of vector addition, therefore, the magnitude of vector P is equal to mod of P vector is equal to simply P. We remove the arrowhead. It represents the magnitude of the vector is equal to side OA of the parallelogram OACB, and the magnitude of vector Q is equal to mod of Q vector, or simply Q, is equal to side OB of the parallelogram OACB, and the magnitude of vector R is equal to mod of vector R is equal to simply R is equal to length of the diagonal OC. Now from point C, draw CD perpendicular on OA, which produce OA at a D. So CD is perpendicular to OD, or CD is perpendicular to AD. Now in parallelogram OACB, OB parallel to AC, therefore angle CAD is equal to angle theta plus phi. These are the corresponding angles. Now in triangle ODC, the triangle ODC, cos theta, which is equal to base upon hypotenuse, is equal to OD upon hypotenuse OC, or this implies cos theta is equal to OA plus AD upon OC, or this implies cos theta is equal to magnitude of vector P plus AD upon magnitude of vector R. Now cross multiply, we get P plus AD is equal to R into cos theta. Let it be equation number 1. Now in triangle ADC, the triangle ADC, AD, which is base, upon AC, which is hypotenuse, it is also equal to cos of angle theta plus phi, or this implies AD is equal to AC into cos theta plus phi. That is AD is equal to Q into cos theta plus phi, because AC equal to OB is equal to magnitude of vector Q. Now put in equation number 1. So we get P plus Q into cos theta plus phi is equal to R into cos theta. Let it be equation number 2. Also from parallelogram law of vector addition, we know that the tan of angle theta, angle between vector P and vector R, is equal to Q into sine of angle between P vector and Q vector, that is Q into sine of theta plus phi upon P plus Q into cos of theta plus phi. Or this implies, because tan theta is equal to sine theta upon cos theta, and it is equal to Q sine theta plus phi now upon P plus Q into cos theta plus phi, which is equal to R cos theta from equation number 2. So put its value R cos theta. Now in the left hand side and right hand side, in the denominator, cos theta cancel with cos theta. So this implies Q into sine theta plus phi upon R is equal to sine theta. Or by solving this, we get Q, magnitude of vector Q is equal to sine theta upon sine theta plus phi into magnitude of vector R. So similarly, we can prove magnitude of vector P is equal to sine of phi upon sine theta plus phi into R, magnitude of vector R. Now in both the equation, the denominator sine theta plus phi into R is same. And if we have to find the magnitude of vector Q, the numerator is sine theta or sine of angle between opposite vector P and vector R. And to find magnitude of vector P, the numerator is sine phi, mean sine of angle between opposite vector Q and vector R. So by this method, we can find the magnitude of component of given vector if the direction is given. That is, angle with the given vectors are given. We can find the magnitude of component of the given vector. So thank you very much.